Hello and welcome to another tutorial. So this time around, what we're going to be doing is we're going to be setting up so that we're able to support having standalone state machines in our AI Behaviours package. So we've already got support for standalone behavior trees. We've got support for, with our GOAP system, having actions that use state machines as well as actions that use behavior trees. But we don't currently have support for standalone state machines. So that's what I want to be getting set up. Now with this, there's actually going to be two parts to this video. So in this first part, I'm going to be doing a little bit of a restructuring, reorganization of the state machines, and also getting some groundwork in there so that we're going to be able to have these up and running. So there's a lot of sort of groundwork we need to get set up. And then in the second video, I'll be actually building the state machines for all of the sort of established test scenes that we have. So that's going to be our focus. So let's begin. So what I want to be doing first is if I go to where we've got our state machine set up, that's actually sort of going to be our starting point of what we need to be working with. So at the moment, we've got things grouped where we have our states, transitions, our SM instance, and so forth. So there's a few things that we're going to get set up with this that we're going to be needing. So one of the things is I want to bring some of the same abstraction that I did with the behavior trees into this. So I'm actually going to have an ISM instance, just for indicating common things in our state machine instance. I'm also going to set up similar thing for having an ISM brain. So the idea is the brain will be for our self-contained state machines. Now with this, I'm going to migrate our interfaces over into another folder, just to group them. And then alongside our SM instance here, I'm also going to set up a new state machine, and this is going to be for our SM brain. So that's our brain base. So that's good. So a couple of key things that we need there. So one of the things that I'm going to do initially is I want to change a little bit of how some of these interfaces are set up, because there's a couple of things I think we can improve upon. So part of this is bringing some of the things from the behavior trees over into the state machines to make stuff cleaner and easier to work with. So one of the things in the behavior trees that does make them have a cleaner and neater interface is that they actually, from the beginning, already know details about the Blackboard and so forth that they're working with. So we're going to bring stuff like that in. So what I'm going to do is, so this is the interface for our state, and we've got current status there. What I'm going to do is make it so we have our ISM instance, and this is going to be for our owner, like that. We're going to have another property for our Blackboard. So linked Blackboard, like that. So having direct access to that Blackboard will make things a lot cleaner and neater. That's going to help out quite a bit. We also are going to have another one here for game object, because one of the common things that we need to often do is access self. So the thing that is, the object that this state machine is sitting on, and that's something that we added into the behavior trees, but works out really nicely. Saves us having to, continually do lookups. We can just actually have a dedicated process for doing that. That's good so far. We do want to set up so that things have to implement a bind to owner. This is going to make it a lot easier for ensuring everything is set up in the right order. So there's going to be quite a few things that we set up that initially might not seem like they're necessary, but they're all about giving the state machine system a bit more robustness and making it that we can use it as both part of our state machine actions and also use it for standalone ones. So that's good. So where we are going to start making changes is things like these evaluate transitions. So we want to get rid of passing in the Blackboard for all 4 of these functions. Now there's quite a lot of files to update with that. So this is something where the safest way to actually do this is, because I know exactly what this is going to look like and because I have been very consistent with following this, I can do a search and replace in the project, and that will allow me to just sort of clean this up a bit. So we get rid of everything. That's good. And we'll tell it to replace all. And because I didn't modify it initially in this one first, it lets me sort of check that it has worked correctly. So that looks good. Now we do the same thing for on enter. Just do this for all of these. This takes away a lot of the manual changing that we would otherwise have to do. Do the same thing for on tick. So we're replacing, we get rid of the comma and the space after it as well. That looks good. And then finally, do a similar thing with on exit. Tell it to replace all. Now, hopefully that has gone and updated most of the files that we need to. We're going to have to go and check to make sure that it has, but that's going to be sort of part of what we do very soon. First, I do want to get our interface for the actual state machine set up because we are making use of this. So that has to be iDebuggable, has to be an interface. And what we're doing with this is a couple of the key things. And if I load up the SM instance, I will be able to see, because this then changes to ISM instance. So a couple of things that are in this get moved over to the other one. So for example, our linked Blackboard and stuff like of that. What I'm going to have here is we'll have a public, sorry, not public, we just have a Blackboard fast name linked Blackboard. So we're making sure we're following consistency throughout. So we have our linked Blackboard, a game object for self, like that. We're going to need a function for binding to the Blackboard, which takes in a Blackboard. And if we take a look in our SM instance, we already have that. So some of these are functions that we've already going to have done an implementation for. Our add state and add default transitions. We want to bring those over. So those are things that every state machine instance needs to support. So this is something that should have really added with the first one. I wasn't going as overboard or as in-depth with setting up interfaces for that, but I very much am prioritizing that with these ones now, because it just makes it easier for then throwing in additional sort of logic later, or even completely sort of swapping out stuff for the state machines. It just enforces a bit more partitioning, which I think is good. So, okay, that's good so far. That's our instance there set up. In terms of the brain, it doesn't need a lot. So we can set that up now so that it's done. And then we can go to fixing up a bunch of the things that we will no doubt have broken as part of setting up the other stuff that we did just before with all of the renaming. So, rename. So this is our linked Blackboard. Now, with the renaming that we did, even if we missed something, it's okay, because it will get quite loudly indicated to us that we've actually sort of missed stuff there. So that's completely fine. There's nothing we need to modify in the transitions, but there is going to be stuff that we need to modify in things like our state machine instance, for example. So this is going to have a lot of things that need to be added and set up. So we've already got the linked Blackboard. Now that needs to change to being public, which is what we ideally want for that anyway. But I will make that a get and a protected set like that. So that's good. So the Blackboard is one of the ones. There's obviously a few things. Self is one of the big ones that's pretty important. So we have our game object self, and what that maps to is linked Blackboard, get game object, common core names self, like that. So that's good. We've got the Blackboard set up, we've got that. Couple of things that we're going to add in now that we've got more of them happening. So when we add a state, we want to bind it to us. So that's an important aspect. Now we'll have a bunch of things that are grumpy, but in most cases can be fixed with a delete. So our tick function on enter can delete. Just deleting these cleans up most of the issues that we have. So that's good. I'm gathering the debug data, all of that looks good. What I will also add in is when we do a reset here, so part of what we're going to be setting up is when we're trying to do a standalone state machine for something that has a whole bunch of discrete behaviors that they themselves have substates, we're actually going to create a new state called a substate. And what it will allow us to do is essentially embed a state machine within a state machine. So with that, we are really sort of changing around the order that we're constructing things in. And what that means is it's very easy for things to not be properly linked. So what I am going to do is add in here when it resets, because we know we always reset early on, we're going to do a state and rebind to owner for this. So force a rebind to owner in case any changes to the tree or to the state machine. That just makes it more reliable for knowing that everything within the state machine will have everything linked up, because that can barrel on down to updating the things as well. So it's just going to keep it a bit more organized. So the rest looks all good. So that's no longer grumpy at us. Now there will be, without a doubt, other things that are grumpy at us. So let's find out how many there are. So for now, it's just complaining about state base. I suspect there's going to be more things than that it gets grumpy at. So, okay. Things that we need to set up in this are those additional properties that we set up because we added in things like our owner, the linked Blackboard, stuff like of that. So let's get those set up here. So we're going to have a public ISM instance owner like that. We're going to have our game object self, and that's going to just map to owner self. So I've got it linking to self. So then there is the Blackboard. So linked Blackboard, and that goes to owner linked Blackboard. So nice and straightforward for it. Now with our adding of transitions, all of that stays exactly the same. Evaluate transitions, we can get rid of that, and we can get rid of that, because evaluate can just use linked Blackboard. We're going to get rid of get owner. That will make a lot of things grumpy, because that was for just getting self, so we don't need that. On enter internal, these change as well. Now these are another one that we're going to want to do our renaming for. So our on enter, our on exit, and on tick internals need to get that rename happening. Reason being is that they will be the main thing that a lot of states are making use of. So we're going to do our replace. I'm going to tell it current project should be enough. We might find that there are other ones we have to update, but we'll take that as we find it. So that's on enter internal. So it updated a bunch of ones. Going to do the same thing for exit. So likely find other ones do get grumpy, which is okay. So far so good. And then the on tick, we also need to update that. So it can be a little dangerous, obviously, using search and replace like this. That's why I am going and using sort of a larger chunk of the function name, so it's going to match reliably. It's also why I updated the interface first, so that the interface being updated will then flow into everything else, and then I can go and fix up everything based upon that. So far that looks good. Now that will have everything set up except for our bind to owner function. So we'll let it create that, and we will populate this because it's quite straightforward of what it needs to do. We would just say owner is in owner, and I will make this virtual because we do have some states that have child states, like our parallel state that we already have. Plus, because we are going to be setting up support for having a state that is able to contain other states, we do need to make sure that we've got that sort of full support there for it. Now, this one is one that's likely to have kicked off even more, as expected, even more errors, which is completely fine. So what this will be, we'll get these updated. So there's a lot of ones here where it's passing in Blackboard. So those change to linked Blackboard. So that's going to be the main change that we do for a lot of these. So that'll make this function one happy. So it'll be a very similar change for most of these ones is what we'll find. So our parallel one, a bunch of these, we actually can get rid of the stuff. So for our parallel one, that makes it a lot easier. Now our parallel one is going to get a couple of additional updates, but we'll revisit it when we have finished sort of adding in these. There's a couple of enhancements we're going to add to it, but I'm going to leave those till later. Now we have things like our move to. So again, this is where we're going to have Blackboard ones. Things like our get owners, we just delete stuff. So a lot of this change is actually just deleting or a minor rename, which is good. That's what we want. So that fixes up move to. We'll have the same with a couple of these other ones. So calculate move location. And again, a lot of ones that are just renaming and deleting. And anything that means less code is always going to be better. Keeping it as simple as possible is good. So then our FSM changes as well, not surprising, because with our FSM, we have some hooks here. So we'll update these. This is for our custom internal states for doing some extra logic. So those and the tooltips are getting in the road. So that's good. Might not have any other ones there that need to be updated. I think that's actually all. It's just that renaming. The other thing that check here, where we had our linked state machine, I will actually make that an ISM instance so that again, even though immediately afterwards I will new it like that, it still means that for anything else that's sort of accessing that linked state machine, it's having to go through that interface. So it just sort of makes that clear and explicit, which is good. So far, so good. Now we get to a whole bunch of ones from our test code. So this is something where, even though we did the search and replace, these didn't update. And that's because if we go to do the search and replace again, what we'll notice is it's based upon current project. So that's okay, because I can repeat the ones that I did before, but now in this new project. So we know that we have on exit internal as well. So it doesn't take us much longer. I could have selected entire solution, and if you've got a lot of ones, that might actually be a good option to go for. Go. So that's good. So then we will have our expected changes for renaming the Blackboard. We're just updating all of these ones. So this is one of those things where, yep, it's a little bit annoying having to go back and refactor and clean up code like this, but it's actually really important for us to do this and to not be afraid to do it. And tools like the rename and following processes like changing the base level stuff first, these make a big difference for sort of the robustness, the reliability of being able to make those changes. And we don't want to leave a bad interface or a bad setup or a suboptimal setup sitting when we don't need to. So that's something where we want to just sort of always be making sure we're willing to go back and clean up the code. Because if you leave it, what happens is, code, even if as long as you're not looking at it, code sort of does tend to start to rot a bit. Especially if you come back and occasionally make changes to it, it ends up, rotting, and you create bigger messes, especially if you're building on top of things that are making particular assumptions. It just gets messy. So I really strongly encourage being willing to go back and take the time to clean up code. It is going to help you in the long run because you end up with better code to begin with. And we're always going to be finding ways to improve stuff, and I think that's a good thing. And like I said, process-wise, I always change the lowest level stuff first, so that then I get a lot of errors, like I'm here, because those errors then serve as a guide to me of what to actually fix. And as I see them disappear, I know that I'm getting closer to having it actually fully fixed up. And then once I get no errors, in theory, I'm actually fully done. So we're most of the way through the errors now. Just got a couple of other ones left, but they are easy ones. And it keeps these interfaces clean, and we're not passing in variables that we don't need to. And as I discovered with the behavior trees, tightly coupling things to stuff like the Blackboard actually works really nicely. It makes things work significantly better. So that's good. We have gone through and done that cleanup of everything. So that's all of those states updated. Now, I did mention with parallel, there was a couple of things that I wanted to be adding to and improving with this. So let's take a look at that first. So one of the things with parallel, especially with how we're going to need to be using it, is we need a bit more flexibility over when it stops actually running. So what I want to have is the option to exit if all are finished, which is currently the default at the moment. So that's one that we will just sort of assume that that's the case. The other one that I want to have is the ability to ignore failures, because that's going to be useful too. So I'm going to have these as properties that get passed, or parameters that get passed in. So I want to have support for ignore failures. And by default, that should be off. By default, I don't want to be ignoring if a node has failed. Then I want my exit if all are finished. And that I actually want to default to true, because in most cases, that's the behavior that I want. So we make sure that we're providing these with the right defaults. So ignore failures, and then exit if all finished. So that's good. So let's implement the usage of those, because that's something that's actually important, because we want to make sure we're using these properly. So if one has failed, well, here I want to check, okay, if we're not ignoring failures, so if we're not ignore failures and we failed, then we exit out. So the supporting for that, quite straightforward. Now, in terms of with this one, if all are finished, well, actually we can check the exit if all are finished and all are finished. So minor change, but it does give us the ability to make sure that we have some flexibility with how these parallel ones behave, because we're going to need to be working with them in a little bit more of a complicated setup for doing the standalone behavior trees. Then, because these have child states and we have that bind to owner set up now, I want to override, oops, not protected, it's a public override, bind to owner. And what we will do is if child states is not equal to null, because this one can be, then for each loop over all of the children, and we're just going to say, okay, well, child bind to owner with the owner. So it just means that that gets passed on down, which is important. So, okay, that's good. That's sort of the changes that we needed to make for our parallel node. Now we can start to get into some of the actual main new bits. So one of the big things that we need to support is we need our sub-state machine. So this is something that is going to be in our core one here. And the idea behind this is a state that contains a state machine itself. So it's going to give us a new class. We'll have SM state, and this is going to be sub-state machine. Good. Actually, I'm going to go for a different name for that. I'm going to call that SM state and a SM container. I think container is a better name for that, actually. So this is actually going to be somewhat involved. There is a fair bit that it needs to do. And the reason for that is it's not just needing to handle the ticking logic for a state. It needs to handle a lot of the logic that actually, if we take a look at our GOP action for FSMs, it needs to do a lot of this. So quite a bit of this logic, so being able to have these internal states, presenting these various interfaces, all of this stuff, we actually need all of that because it has to hold that state machine and it needs to wrangle all of the updating of it. So my starting point for this is actually going to be to take these and bring them over because it is a core set of stuff that this needs. There's going to be other things it needs, but this is one of the big sets of things that are absolutely critical for it to have. It needs to have that linked state machine. So that's good. So unlike for the GOP action, this is going to need a constructor similar to what we have for our other states. So this is going to have our container one. It's going to have that optional display name that we can then pass in to the base like that. Now, in terms of what this does is, okay, well, the initial thing it needs to do is set up these failed and finished states. Because if we take a look at our GOP action one and what it does, it's actually the first thing it does is it sets those up. So we want to be doing the same thing here. So a lot of this logic comes over, but not all of it. There's going to be further of this logic that we need to bring over. We certainly do need to bring over things like the failed behavior and also the finished one. So those get brought over. There will be further changes that we do also make to this. So there's going to be other bits that we set up with this. Now our GOP action FSM, if we look down further, we have these handler functions. Well, we need those. And our adding of the stuff here in terms of states and default transitions, we need those too. So we're going to bring those over as well. But we are going to make a couple of modifications. Because add default transitions actually needs to work differently. I don't want external things to be able to actually sub in different ones here. That's not how this should work. Because it needs to have ownership of what those transitions are. So this won't be an add default transition. This will actually be public, and this will be finish construction. And it's just going to, by default, always do our linking to those ones that we have set up. So I don't want the user to be able to override that. That needs to be under our control. And that's actually really important that it is under our control so that we can actually make sure that it's behaving the way that it needs to. So, okay, so far so good. This side we can collapse. We've got our different parts set up there. We are handling the failed and the finished, everything like of that. We do need to add in our debugger support. So that's another part that has to get added in here. I'm going to put that in, I think near the top makes sense. So that's reasonably straightforward. That's protected, override, gather debug data internal. Now what this needs to do is that's going to then go, well, linked state machine, I want you to gather your debug data like that. So nothing overly complicated it needs to do there. The state machine resetting, I'm actually going to, because it would be helpful to sort of wrap the logic because we are sort of repeating ourselves a little bit. I'm going to have a reset state machine that does these two lines. Because then these will just change to reset state machine. Just using it in a couple of places, and I don't like duplicating that logic. So that just makes it a little bit cleaner and neater. So okay, we've got the hooks here for these completing. I think that's okay, because if we did something that overrided the container, we do want to be able to provide our own implementations for that. So I think that's good. We want to have public override for bind to owner, because this one's pretty important. This needs to linked state machine, bind to Blackboard in owner and the linked Blackboard. So that's a necessary one that we have to make sure happens. Our add state is completely fine like that. Finish construction is good like that. We do want to clean up some stuff in terms of there are actually other things that we want to override for this. So we want to override that on enter internal. The reason being, well, we actually have to implement it because we're implementing state base, but we want to not force children to implement this, which is why we're overriding it. But also, we actually specifically want to tell the linked state machine to be reset. We're not using our reset function because it shouldn't run the full reset logic because it doesn't actually need to. This is a very specific case where we've entered this state. We want to just reset everything for the first time, and we don't need to send the reset notifications. Those reset notifications are for after work has actually been done, not for that sort of initial case. So that's good. Exit. We want to set up it as well. Now with it, I'm also going to reset the state machine at that point. So that's good. So far, all of that is looking good. So we've handled our on enter, we've handled our on exit. The main thing then is our on tick. So we have our protected override and our on tick. So one of the things with doing this tick is we need to be able to return our state status. We need to map from sort of the result of ticking the state machine to that, which is straightforward. But as a result of just doing on enter, the state machine actually could have finished, could be completely done at this particular point. Once we've run sort of the any entry logic there. So what I'm going to do is I am going to set up a ESM state status and make this nullable. So pending tick result. And then here, when we failed, well, our pending tick result is failed. And here, our pending tick result is finished. That's because this is the main way of running these two functions is the main way that a state machine indicates that it succeeded or failed. So we have to hook into this. And then what I would do further down here is I'm going to, in our onEnter, I'm going to set pending tick result to null. Then in our onTick internal, if our pending tick result is valid, then we just return it. So we just immediately return it. We don't need to do anything else. Otherwise, we get our result and we're going to linked state machine. We will tick it with passing through the time. Now, if that result failed, so if we failed, actually I can just do this in one line. So return, if our result is equal to failed, then our state status is also failed. Otherwise, our state status is running. So that's good. So we are hooking into the normal methods that we would use for indicating if something has sort of succeeded or failed. So that's good. That will give us, we'll just make sure there's no errors, which there's not. So now we have our substate, or our state machine container essentially, that we can make use of for holding the contents of a state. Because if we think to stuff like our RTS AI, it has a whole set of states that perform gather. So we can put those into one state machine container. We have wander, that can be another container. Same with things like idle. Look at can also be a separate container. So it gives us the ability to wrap a state machine and put it inside other ones. And with things like our parallel node, it means we can have multiple state machines actually running at the same time. And that's in part why with parallel, we needed to add in these additional options, is to give us that flexibility, that capability to actually do what we need to there. So, okay, so far so good. We've added in all of those different things, quite a lot of bits that we've added. We're not going to get to implementing the actual state machines themselves yet, because there's quite a lot we need to do for that. One of the things we also need to do, though, set up for this is this SM brain base. So this is pretty important. This is going to be abstract. And this is going to serve a lot of the similar purposes to the behavior tree brain base. So it's a similar possibility. So it's a similar purpose to it. So it's still a mono behavior. And this implements our ISM brain interface. And then this is going to need a lot of similar things to the action and to the SM container. It's actually a lot of similarity there in terms of what stuff we have to actually set up, which is not really surprising because they're needing to do very similar things. So let's go through that process of getting those things sort of set up. So some of the stuff will carry over directly. So stuff like our linked state machine, all of those different ones, those carry over. There is also going to be stuff from the brain base that gets brought over. So this has common things. So there's a few sort of things that we're mixing and matching from different ones. And that we're going to need to be adapting. So it's sort of pulling things from a lot of different locations. I think in future, what I would likely be able to do is set up a common base that all of them use. That's populating a bunch of stuff. I think it's sort of in the realm now where it could feasibly be doing that, which would be quite handy. So we need to kind of decide where we start bringing sections across from. So I think the Gope Action FSM is probably a good starting point in terms of stuff to bring over. We do need our state machine finished state, because that's a big part of a lot of the helper logic that we have. In our brain base, then we've got a lot of these things like our resource capacity, our link navigation. Those absolutely have to come over because we're trying to ensure there's consistency between these. So I'm going to bring those, but I'm also going to collapse that. So, okay, we'll have the Blackboard. Now the brain next would have the behavior tree. In our case, we would have the linked state machine. And we will also have those internal states there. So we'll bring those over. That's good. So we've got our linked state machine. There's other bits that we have to set up. So we have in our brain base things like our debug display name and that self. Those are necessary. Bring those over. So there's progressively going to be less that it's getting grumpy about, which is good. So, okay, so far so good. That's a bunch of things brought over. Our start function from here needs to come over pretty identically. All of this stuff for locating the nav interface, all of these things where we're populating the Blackboard, all of that is common. Same for the actual setup there in terms of when we're doing a destroy. So I'm going to bring over pretty much, I think, everything, including the update. We might also bring over the get debuggable object content. So there's a lot of stuff that is identical, especially to things we've already implemented. So get debuggable object, that one's going to talk to our state machine. Now the things that change here is, okay, well, we need to early on, and this is pretty important, we want to make sure we've got these brought over because those have to be set up. So we have our those internal states created. All of the populating of the Blackboard is fine. There are things it's going to be grumpy about that are going to require us to make a couple of changes to the assembly definition. We'll take a look at that in a moment. I want to just get this general structure set up. So in terms of order, configuring the Blackboard still makes sense. Then binding the state machine to the Blackboard also makes sense. So we would do a bind to Blackboard with our linked Blackboard like that. Well, we wouldn't be configuring the behavior tree. We'd configure the FSM. And then we do want to do a reset. We could just do a straight reset like that. So those don't change. Those are exactly the same. Our on destroy, exactly the same. Our update, that all looks good. Still has that brain logic, should still be doing things the same way. So that's good. So as much as possible, I want to keep consistency between how these are actually working. So this is again one where our tick brain, we will bring that over because that is going to be largely the same. We haven't set up our pre-tick functions or things like of that. Now our tick logic here is simpler because we know that the actual result is going to be fed through by those little helper states that we set up. Those are our way that the state machine communicates externally. So for us, this actually is pretty straightforward. We can just tell the linked state machine to tick with the delta time. So it's a little bit simpler, but mostly because it has to do very little. We need support for resetting the state machine. That's one where I would use the same logic that we did with these. So we'll have our reset state machine function that I will bring over. So far so good. We have our reset state machine. We want to have those same functions that we set up for the internal completion, like we have with these. We don't need to worry about that pending result though, but we do also want these other helper functions. So we're just going to bring over a whole lot of those. So there's a lot of similarity between the brain base and the substate, which is not surprising. There should be a lot of similarity to it because it's needing to do very similar things. It's the same as why there's a lot of similarity to the FSM action. They work with it in slightly different ways, but they are largely very similar in terms of the things that they're needing to be doing. We do want to bring over things like what we had more for our state machine with our add state and our add default transitions. Those actually make sense to come over as they are, because those are working with it exactly. So the brain ends up being a bit of a mix of our FSM state, of our GOP action FSM and our standalone sort of substate for them. So it's a bit of an interesting mix there that we get with it. And similar thing where we have all of these configure functions and all these pre-tick ones, those actually should also come over, except that ends up being configure FSM. Now with that, that's actually largely it. It's got all of our tick logic, it's hooked into the debugger, it's a fair bit of code, but it's actually very little new code. Because it's just linking into things that we already have. Now it is grumpy at us here, and the reason for that is if we go to our state machine and the assembly definition here, we need to add in a reference to our framework essentials and apply that. And then once it's thought about it, it should be a little bit happier. We might find that we need to add in some additional usings up the top. That's probably the most likely. But actually, no, it's back happy. Unity's just taking a little bit to catch up. There we go. So it just needed us to go to Visual Studio and back for it to sort of update. So that's good. We have our state machines cleaned up. We've cleaned up how they work with Blackboards. We've given them that additional tracking of things, all of that stuff that's going to help make it significantly easier for setting up those standalone ones, because those standalone ones are going to be sort of quite important. And what we should do, because we have gone and made a lot of changes, is we should just double check that we have not gone and completely broken the normal state machines, because that would be very, very bad if we had. So we'll just test, and they're still doing their thing. We still get our debug output. They're moving between the different states correctly. All of that's working, parallel. So none of the changes that we've made have caused any issues with the systems we've already got, which is great. So now that we've got that solid base, we're going to be able to set up our state machines for the different scenarios that we have. That is something that I'll be covering in the next tutorial. I'm splitting that off from this one just so that this isn't too ridiculously long. It's a bit more manageable. Now, if you're wanting to jump ahead and grab the code for that, that code is already going to be up and available so you can access it. So you've got already access to that, plus also the completed package is available there as well. So dive on in and experiment with that. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, there are 3 links in the description below. The first is a link to the code as it was at the very start of this video. The second is a link to the code as it is right now. And the third is a link to the completed Unity package. So you can jump in at any particular point that you're wanting to there with this. You can use that code freely in any of your own projects, commercial and non-commercial ones. If you've got any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description also. But until next time,